Today we're going to look at a special type of factoring on something called a difference of squares. In this example, we're given two binomials, a plus b times a minus b. So we'll expand them, simplify them, and see how these can be factored in a slightly different way. So x plus 9 times x minus 9. The x's are the same, the 9's are the same, but the signs are different. Now when we expand this, x squared minus 9x plus 9x minus 81. The negative 9x and the positive 9x cancel out, and we're left with a value of x squared x squared minus 81. Here we have a similar example. We have two x's and we have two 4's separated by a positive and a negative sign. So x plus 4 times x minus 4. When we multiply the x's together, we get x squared minus 4x plus 4x minus 16. Collecting the like terms, we're left with x squared minus 16. In this example, 2x plus 5 times 2x minus 5. 2x times 2x gives us 4x squared. 2x times negative 5 gives us negative 10x. 5 times 2x gives us positive 2x. 5 times negative 5 minus 25. The negative 10x and the positive 10 cancel out, and we're left with 4x squared minus 25. So there's a pattern at work here, and when we learn to spot the pattern, it makes it quite a bit easier to factor, or possible to factor, these types of terms. So an example where we have a plus b multiplied by a minus b, we'll end up with a squared minus b squared. The result is called a difference of squares, two perfect squares being subtracted. So note that these are perfect squares, a squared and b squared. Can both, you can get the square root of both of them. Square root of a squared is a. The square root of b squared is b. So you need three things to exist in order to have a difference of squares. You need two terms, both where you're able to get a square root, and these two terms need to be separated by a negative sign, a subtraction sign. So we look at the first example, x squared. We ask ourselves, can we get a square root of x squared? Yes, we can. The square root of x squared is x. Look at the 16. Can we get a square root of 16? Yes, we can. Square root of 16 is 4. Is x squared and 16 separated by a subtraction sign? Yes. So we have an example where we have a difference of squares. In the next example, 4y squared. Well, the square root of 4y squared is 2y. 49, the square root of 49 is 7. These two terms, 4y squared and 49, are separated by subtraction sign, so we have a situation where we have a difference of squares. Factoring a difference of squares. Well, there's a very set method for doing this. We simply take the square root of the first term, put it at the beginning of both brackets. We take the square root of the second term, put it at the end of both brackets, and then we put in a positive and a negative sign for each respectively. So here we have x squared minus 64. We start by taking the square root of x squared. The square root of x squared is x. So we put that result at the beginning of both brackets. So we put an x at the beginning of the first bracket, an x at the beginning of the second bracket. Then we look at the next term, 64. The square root of 64 is 8. We put in our 8's there, and then we simply write in a negative and a positive sign. Or you could write in a positive and a negative sign. It doesn't matter. X squared minus 16. We have two terms. They can both be calculated to have a square root, and they're separated by a negative sign. It's a difference of squares. To factor it, we just take the square root of the first term, which is x, place them as such. Then we look at the second term, take the square root of that term, which is 4, put them here, and just write in a negative and a positive sign. 5x squared minus 36. Looking at the 25x squared, if we're trying to determine the square root of it, it might be simpler or helpful to do it in two steps. The square root of 25 is 5, and the square root of x squared is x. Put together, the square root of 25x squared is 5x. Write them into our brackets. Look at the next term. The square root of 36 is 6. Place them there. Separate it by a positive and then a negative, or a negative and a positive. Either way works. 9x squared minus 121. The square root of 9x squared. This is supposed to say 9x squared. Please forgive the typo. Is 3x. Put that into our brackets. The square root of 121 is 11. Put that into our brackets. Then put a negative and a positive, or a positive and a negative. And there's our answer factored. Now, in these examples, looking at 2x squared, there is not a square root for 2x squared, not an even one at least. And there's not a square root of 50. However, if we simplify it by and use a common factor first, we will be able to use the difference of squares. So the greatest common factor between 2x squared and 50 happens to be 2. Once we've common factored it using the greatest common factor 2, we're left with 2 bracket x squared minus 25. Now, the x squared minus 25 can use the difference of square method. So, we write in our 2, ask ourselves, what is the square root of x squared? That's x. What is the square root of 25? That's 5. Put in our negative and our positive, and we've factored 2x squared minus 50. Looking at 3x squared minus 48, again, neither of these terms can be calculated to have an even square root, but if we use common factoring first, we'll be able to reduce this to a point where we would be able to use difference of squares. So, our greatest common factor in this case happens to be 3. So we can rewrite this as 3 bracket x squared minus 16. Now, what we have inside the brackets can be factored using a difference of squares. We write in our 3 with our brackets. We look at x squared. And the square root of x squared is x. Square root of 16 is 4. Put in our negative and positive signs, and we have it fully factored. (5x squared minus 500). First, we use a greatest common factor, which in this case happens to be 5. Rewrite it as 5 bracket x squared minus 100. Write the greatest common factor, followed by 2 brackets. Square root of x squared is x. Square root of 100 is 10. Place our negative and positive signs, and we're done. This example, 75x squared minus 27, can be further reduced using a common factor of 3, rewriting it as 3 bracket 25x squared minus 9. Put our greatest common factor on the outside, write in our brackets. 25x squared can be reduced to, well, take the square root of 25x squared. It gives us 5x. Take the square root of 9, gives us 3. Put in our negative and positive sign. In this word problem, we're told the area of a desktop is represented by the expression 2500 minus x squared. Determine the length and the width of the desk. So the area represents length times width. So we want to try and get some term that represents the length, and we want to get some term that represents the width. We want to multiply something times something. To do this, we can use the difference of squares. We'll take the square root of 2500 and the square root of x squared. So the square root of 2500 is 50. The square root of x squared is x. Now we have something multiplied by something, which in this case is our length. 50 minus x will be the smaller term, so 50 minus x we'll call the width, and 50 plus x we'll call the length. So the width is 50 minus x, and the length is 50 plus x. If x is given a value of 10, we can simply plug in those values to wherever x is. So our length will be 50 plus x, or 50 plus 10. So we can determine that the desk has a length of 60 centimeters. The width is represented by the expression 50 minus x. 50 minus 10 equals 40 centimeters. So we have a length of 60 centimeters, a width of 40 centimeters. We could plug that into an area expression where area is length times width, substituting in our 10 as our value for x and get 2,400 centimeters. We could also have simply multiplied 60 times 40 and we would have been given the same result. At any rate, the area of this desk is 2,400 centimeters squared.